On these problems, we're supposed to find the measure of angle B. So you're just having to apply a lot of the different things you learned. So these are applications of the things that we learned. So for example, in number 14, one of the things we learned is that when two lines intersect, right, then the angles that share the vertex and the extended rays, right, those are called vertical angles, and they are congruent, right? So this is congruent to this, and this extra line right here is just there to sort of clutter it up and see if you really understand how to identify vertical angles in a bigger picture of things going on. So these two are vertical angles because you take this line and extend it, and it's one side of both angles. You take this line and extend it, and it's one side of both angles, and they share the vertex. They're across from each other. So because we know these are vertical angles, then we know they're congruent. So B has to be 46. The measure of angle B equals 46 degrees. And the reasoning, again, if you had to provide reasoning, would be because they're vertical angles. Right here, we're going to apply the angle addition postulate, where if two angles are adjacent, right, then you can add their angles together to get the larger angle. And we know that this larger angle, because of this is 90 degrees right here, and if this is 90 degrees, then this has to be 90 degrees, right? So because this has to be 90 degrees, then the two of these angles have to add up to 90 degrees. And if they have to add up to 90 degrees, then taking 90 minus 39 will give me the measure of angle B. So measure of angle B has to equal 51 degrees if the two of them are going to add up by the angle addition postulate to 90 degrees. So that's 51, not 57. And I'll do one more related to parallel lines. So that's like the vertical angle theorem that we applied there. The angle addition postulate